Standard reaction enthalpies are easily calculated from tabulated values of standard enthalpies of formation. Okay, so why is that? It's really just an application of Hess's law. Imagine your reactants, change it to elements in their standard state. What would be the delta H for that? That will just be the negative of the delta H formation of your reactants. Why? That's just the opposite of making it from the elements, right? Okay. Now imagine the elements in their standard state now, change them to products. What's the delta H for that? That's just the delta H of formation of the products. You're making it from the elements in their standard state. And you have to add it up for all the reactants and add up all the numbers for the products. So if you combine this equation and this equation, these two reactions, what do you get? You have the overall reaction where you have reactants end up as products. So what's the delta H for this overall reaction? The sum of these two. So negative delta H formation of reactants plus delta H formation of the products. Or you can say delta H formation of products minus delta H formation of the reactants. Okay? So that's the beauty of tabulating standard enthalpies of formation. You just need, for any reaction that you have, you just look up the standard enthalpies of formation, then you just take products, the values for the products, subtract the values for the reactants, you get the delta H for the reaction. All right, so let's illustrate that with an example right here. Let's say you look at the delta H formation of the reactants and products involved here, and they happen to be W, X, Y, and Z. What's your delta H for the reaction? It's delta H formation of the products, right? Minus delta H formation of the reactants. So what would it be for products? Y plus 2Z. Why 2Z? 2 moles. Because the numbers I have given here are kilojoules per mole. Okay? Minus reactants would be W plus 2X. Okay? Can I simplify this? Y plus 2Z minus W. Like that? Y. What is X? This is O2 gas. That's an element in its standard state, so that is 0, right? So where can we find these values? You should be able to find these delta H formation in tables at the end of your book. Or you can look it up on the web. A good source of these values would be webbook.nist.gov. So let me show you where you can find that. webbook.nist.gov. Okay. So when you get there, click on NIST Chemistry Web Book, and you can do a search for a formula. For example, if I want to know CO2, carbon dioxide, I want to know delta H formation. I want thermodynamic data for the gas phase. So I just check that box right there. I hit search, and I'll find here, okay, delta H formation of carbon dioxide is negative 393.51 plus or minus 0.13, and the units here, is kilojoules per mole. Okay, and it gives you the reference, primary reference for that value. Okay, so you may see several values from different sources. So that's a good source of information. Heat capacity also, you can look it up in case you needed it. Heat capacity actually in general depends on temperature, and so this is the formula that you can use to calculate the heat capacity per mole. And you have some constants that you can plug into that equation right there. Okay? So that would be a good source for finding delta H of formation.